Thanks, everybody. So, I'm going to talk about Pact here, but one thing I do want to announce is, of course, that we launched our, we released our mining platform. And that's been running since Thursday, so that's and that has Pact running in it because Pact implements our coin management. So, as the author of Pact, I'm very excited about that. So. One of the things, so what I want to talk about tonight was take you through, just take you through some of the new things that we've done in Pact recently and that are rolling out with the public blockchain as well as available on our testnet and also on our private blockchain Kuro, and of course on other platforms as we'll talk about. A little about Pact, just that's our smart contract language. I wrote Pact in 2016. It's open source. We designed Pact to be simple and safe, but powerful. The idea there was that you want to protect developers from themselves a little, but you also want to give them a lot of functionality. Pact is a rich set of natives and things like that. So there's a lot of things you can do in Pact very easily that would be very difficult to do in other languages. One of the things about Pact is that it's an interpreted language, so it's human readable on the blockchain, which means that, like, if you use a block explorer and you go and look at a transaction, you're going to see the actual code they're trying to run, like whether it was a transfer or some kind of specific smart contract. It makes a big difference in terms of being able to support the platform, but it also just makes it very elusive for everybody who uses it. It's got formal verification in a way that is very simple to use, where you can define properties in such a way that we can use the Z3 theorem prover to find bugs in your code. And most importantly, as I said, it's in production. It's very exciting to see this thing go live. And all it's doing is coin rewards right now, but it is doing the thing. So the key concepts I wanted to take you through tonight that really kind of shape the new features that have come out of Pact are guards and capabilities. So Pact launched with a thing called key sets, and the idea was that we wanted to make it that it's very easy. It's not just easy for a developer to verify a signature. We wanted to make it easy for a developer to verify multiple signatures, so that at any time you could take advantage of the enhanced security of like a multi-sig contract or something like that, or you could have multiple multi-sig contracts, all happening within the same code base. And we wanted to make it that a developer doesn't have to do anything to make that real. And that was called key sets. But what we quickly realized is that you imagine something like a token ledger, and you put a key set next to an amount, and that's great. But then there's other things that we'd like to be able to do to say something, to make other things be able to dictate how a value is transmitted and owned in the blockchain. And that's really what guards are. So we have other models now that interoperate with it, including module guards, which are like Ethereum. So Ethereum allows a contract to own money. So we have that in the sense that you can decide to say that something is guarded by a module, which is the fundamental unit of a smart contract in Pact. We also have Pact guards, and these are, Pacts represent some kind of transaction that is taking place over some predefined amount of steps, like an escrow. An escrow would be something where you escrow the money, and then some real world thing happens, and then you're able to redeem the funds that are trapped in escrow. The idea now is that a developer doesn't have to do any special code, can just use a Pact guard to guard that fund while the Pact is running. But the most exciting one is the user guard. And the user guard is basically a way to say that you can write any code you want within certain boundaries, and that code will govern who owns the amount in the value in the blockchain. And the really obvious one is something like HTLC, which is what powers the Lightning Network. So this is something where instead of a signature, you have a hash secret, and you also have a timeout. So the idea being that within some kind of timeout, being able to present some secret to the blockchain that isn't a private key allows you to access the funds. So these are the kinds of things. You can have all these coexisting in the same ledger, and a developer doesn't have to do anything for this to be true. So guards represent a very flexible model for ownership on the blockchain. The other thing we introduced was a concept called capabilities. And this comes out of 50 years of research into secure computing, and there's a gentleman who's somewhere around here who's very heavy into that, who's going to probably criticize every single thing I say about this, but that's okay.
You left, it's okay.
But the main concept behind capabilities is that you want to have no authorization without designation. And blockchains are already very good at this. Blockchains already have this concept that you sign something, and that very specifically says that you want some transaction to happen on the blockchain, and public key cryptography makes it that that's a safe operation that nobody else can do. But since Pact is a multi, and we like to say many, signature environment, that can actually get kind of hairy when you've got like 5 signatures in a single transaction that might be doing different things. So for instance, on a blockchain, one of the things you might want to do is pay for gas. Another thing you might want to do on a blockchain is transfer money from yourself to some other individual. Now those might be different accounts. So capabilities allow you to say that one of the things that capabilities allows is this concept of scoped signatures. It allows you to say, this signature is for this, and this signature is for that. The other thing that capabilities introduce is this concept of a managed right, or a managed capability, in the sense that I'm going to grant to somebody, or I'm going to grant to this transaction, the ability to do something 1 time, or 2 times, or up to a particular amount. So as we'll see, and we'll go through this a little more as we go through some of the use cases for this kind of thing, but the idea that you can work with multiple trust sources and safely delegate them to different actions within a transaction is what capabilities really makes possible. So let's look at one of the bugbears of smart contracts today, and that's ERC20 interactions on Ethereum. So today with an ERC20, what works great is going to an ERC20 and transferring it to someone else. But unfortunately, we want to be able to do a lot more things with ERC20s than that. We want to be able to delegate to someone else to be able to do that for me, or we might want to send that to not a person, but a smart contract. We might want to actually send funds to somebody that isn't sitting around watching their balance, but is actually an autonomous entity on the blockchain. Unfortunately, both of these things are very, very hard to do in Ethereum. If you want to delegate the authority to somebody else who you use approve and transfer from, which is subject to a number of attacks, including front running and many other things, because it's just not a very safe way to do that. And then the other thing is, if you send it to a smart contract, and the smart contract is not linked up with a whole bunch of basically code to look at logs and be able to say, oh, some event happened and now I'm going to go dig through the history to figure out what changed, you can lose coins forever. So you can send money to a smart contract. Because the developer did not specifically code that smart contract to receive your money, the money is lost forever. And there are millions of lost ERC20 tokens because of this. This is a well-known problem with ERC20. And as a result, it's created a cottage industry of standards. All they want to do is specify, how can we do on behalf of transfers? How can we whitelist some people to be able to transfer and other people not? How can we put amounts on them? And there's at least 5 that come to mind immediately, and we have a different solution. So with Pact and Kadena, the idea is we have this notion, there's kind of 2 scopes for this. One is allowing someone else to allowing someone else to pay themselves. And then the other one is allowing somebody at some time in the future to do a transaction on your behalf. So there's 2 sides to this. The first side is, I want to go to a smart contract that has something that I want to do. And I want to make it so that that smart contract can just pay itself. And the way you do that is with what we call a managed capability. So let's talk about, I'm going to run a smart contract, and I just want, for the service I'm getting, I want it to get 10 Kadena coins. all I have to do is when I sign the transaction, I have to attach this coin transfer capability to the signature. It's got me, whatever my identity is, and the third party in it, and it's got the amount. Now what this does is it doesn't actually make a transfer happen. It creates a circumstance inside of the transaction that allows that third-party application to directly invoke the coin contract on my behalf safely, because it could only do it up to $10 or 10 Kadena. This is something that now the smart contract doesn't have to wait for me to transfer to it and then have to do a bunch of bookkeeping after the fact that could have bugs. It can just directly transfer the money. And I know as the user that it can't transfer more than $10. The other way that this can work is that you can delegate, because of guards and the flexibility of guards, you can create a special account just for, say you want an exchange to be able to trade on your behalf. You can create a new account and put a guard into that account such that the exchange can trade for you, and maybe there's a time limit, after which you can go, say after a week, you could go and say, okay, I want my coins back. Or you can do other things with capabilities. You could say that the exchange can only trade, any kind of data-driven thing you want to do, capabilities can let you do. So you could say, I only want to trade in increments of 5, or I want to trade down to this kind of minimum balance. The point is that these things are just defined in normal Pact code, so you can model anything you want. And most importantly, it creates an airtight model for you to be able to delegate safely the ability to transact on your behalf to a third party. And as a result, we have no need for whitelists or STO standards. We can have just a single standard for an ERC20. We call it fungible. And our coin contract already implements this, so there's no need for WETH or any of these things. You can directly interoperate with our coin and with any coin that somebody wants, any token that someone wants to model on the platform. And you benefit from all these things without having to adopt some arcane standard or make some kind of arbitrary choice about who you think modeled this right, because it just works. Another thing that comes from these new features is the ability to solve one of the most vexing problems in UX for users adopting blockchain. Now, of course, crypto is just hard to adopt. It still is the kind of thing that most people are going to be scared of it. And I'm not talking about that. I'm talking about a problem of people who've already decided they want to use a dApp, and then all of a sudden they have to actually own the underlying. They want to use the dApp. They don't care about ETH. They don't care about the Kadena token. They don't care about Bitcoin. They want to use a gambling app or some kind of, whatever they want to do. They don't want to think about the underlying token. And right now on Ethereum or any other normal gas-paying architecture, they have to they have to own a little bit of Ethereum in order to pay for their transaction. So remember I said before that one of the things you can do with capabilities is you can attach a capability to a signature. So one of the things we can do right off the bat is we can say that a signature in a Pact transaction is scoped to gas, and that's a special capability that's defined in our coin contract. So that immediately presents a solution for a dApp developer. A dApp developer can now have the user sign for whatever interaction they want to do with the dApp, and that might be to bet something or to stake something or whatever is going on within the dApp and within the dApp's token. But meanwhile, they can use, the developer can make it that the user uses the developer's account to pay for gas, and that can be done safely. And that's because Pact allows multiple signatures on a transaction. So you can present it to the user's wallet, you can get a signature for their interaction with your dApp, and then you can send it off to a server somewhere, where you've got an HSM or something like that, and you can add your signature to the transaction as a dApp developer, pay for gas for the user. So already that solves the problem of gas for many smart contract developers, but it gets better. The second thing we can do is that Kadena, or anybody, but this is something we're planning to do, is that because you can model this as a guard, you can have a guard in an account that checks for the presence of a particular capability, and in this case it's gas. We can make accounts that are only for paying for gas, and they're only for certain kinds of community ventures. So we can say that people are doing stuff that's for the public good. you know what, we're going to fund that. We're going to make it that your gas is free. Because, you know, gas isn't that expensive. We could put like, you know, $5,000 worth of Kadena coin into an account and say that for these kinds of use cases, you're never going to have to pay for gas. And all you have to do is put the right sender on that and it's done. So that's something that only the Kadena blockchain can do. The last thing is something we're really excited about, which is what we call the gas payer API. And this allows for a smart contract to actually register itself. It's not a registration process, but the smart contract has the user attach a capability that is defined by what we call the gas payer API. And this indicates that the smart contract is willing to pay for gas. And now the coin contract will interact with that smart contract, present the user's credentials, and the smart contract can decide in real time if it wants to pay for that user's gas, and it can do all sorts of things like update its own internal ledger. It can do whatever it needs to track that. So that's pretty exciting. But I think the more exciting part is that it actually creates new business opportunities in the sense that now you can have smart contract developers whose whole goal in life is to, you know, work out gas prices and figure out, you know, some kind of economic model for that so that they can provide it as a service to other dApp developers. So now you could be a dApp developer who doesn't know a thing about gas and doesn't want to. But what they're willing to do is pay a small amount of, you know, pay a fee on every transaction to your service, and you will take care of subsidizing their gas. And that's all made possible because we have this flexible model of regards to capabilities. So the last thing I wanted to talk about tonight is that in addition to Pact running on the Kadena blockchain today and running with many of our use cases on the Kuro private blockchain, we've made strides to port the Pact smart contract language to the Cosmos ecosystem with Kadenamint. So with Kadenamint, we have made it possible to write smart contract applications in a much easier way on the Cosmos platform. Right now with Cosmos, the way you write an application is you actually kind of build a little blockchain in Go and launch it. And that's, you know, that's fairly involved. You have to hire some pretty good Go developers to be able to do that. Pact is a much easier language, it's much safer, and so this opens up new avenues for the Cosmos ecosystem to have developers create new applications. Also, Cosmos is in the process of finalizing IBC, which is what really brings the Cosmos vision to fore. And that is the ability for smart contracts to do safe interactions between different hubs in the Cosmos ecosystem. Pact is going to be a first-class citizen in there because Pact has the right ingredients to make it easy for smart contracts to work with IBC and to actually build new solutions that leverage the vision of the Cosmos ecosystem. What's also exciting is that we are working with other major blockchain platforms that you've heard of, but we can't announce just yet, to bring Pact to their platform. And what this really realizes is that when we built Pact and we wanted to make it simple, safe, and powerful, we also wanted it to be a standard, so that way people people will know that there's a solution out there that lets you quickly write smart contracts that get the job done and won't lose millions of dollars in some kind of crazy bug. We want Pact to be the universal standard for smart contracts. Kadenamint is the first big move to move it out of the Kadena ecosystem and make it that eventually the Kadena platform, the Cosmos platform, our hybrid integrations with private blockchain, all of these things can work in a single, seamless, larger ecosystem, which we think is going to make it much better to write smart contracts on the blockchain. So we encourage you to check out Pact. There's some amazing tutorials at pactlang.org, both tutorials and videos. They can get you up and running with Pact really quickly. Doug's going to come on and show you pact.kadena.io, which is our web editor, which is also which is closely related to our wallet. There's many very exciting features in there. You can participate. We're going to launch the full transactional system in early December, so if you want to develop applications, you can start participating in our testnet and rolling out applications of that to be ready to bring applications to our full launch on December 5th of the Kadena public blockchain. Thank you very much.
Okay, thanks for coming. Thanks, Stuart. I'm Doug Beardsley, Director of Engineering at Kadena, and I would like to show you some of the tools that we have for working with Pact and our blockchain that we're really excited about. So pact.kadena.io started out as just an easy on-ramp to get started writing Pact code. A web REPL, as it were. It has some things in common with an IDE. It also has some wallet things in common, and it is evolving into what is going to become Chainweaver, our desktop wallet, which we launched recently, and we have another big update coming at the end of this month. So you want to write some Pact code, go to this website, and we have a little editor here on the left-hand side. You can write your code, you can hit load, and it loads it into running in your browser. On the right-hand side, you can evaluate things right in the browser, play around very quickly and easily. It takes very little to get up and running. This right-hand side of the application also has a module explorer, which is connected to our blockchain. If you go up to this little cog menu, you can add networks, and you can see right now it's connected to our testnet. At the moment, we have disabled it from talking to mainnet because we don't want people to start using less secure wallet and key functionality than we think is appropriate for real coins on a mainnet. And so that's what we are headed towards there. We have a few example contracts, which we'll get to in a second. The deployed contracts have, this is what has been deployed to our testnet. We have a coin contract. As you can see, we have a coin faucet, a few interfaces, a gas payer example, and we have some games that we're playing with that I'll show you in a minute. Now, Stuart mentioned that Pact has formal verification. We're really excited that we actually have this formal verification available here in the browser, and it lets you verify your code and become much more confident about what your code is actually doing. So how does that work? I have this little function, abs_bug. It's a simple absolute value function. Nothing complicated going on here, except that I coded a very complicated condition, and if that condition is true, we return -1, which is not something that you want a well-behaved absolute value function to do. Otherwise, do the right thing. Now, I pose a question to the room. What value do you have to pass into this absolute value function to make it return -1? What value causes the bug? And I won't wait too long because we intentionally constructed this to be an inscrutable high school algebra equation that you have to solve in order to figure this out. But if we hover over our formal verification warning here, it tells us exactly what value is going to make this function fail. How did this happen? Here on line 19, we declared a model, and we're trying to make sure that the property that the result is always greater than or equal to 0 is true. The formal verification sees this, and it is able, thanks to a bunch of things, in part the simple language design of Pact enables this, and a lot of great work in actually implementing this and tying it into a theorem prover. We can prove that for all possible values of this input, the function behaves the way we want. And that is how the formal verification system is able to tell us that at a value of -4,839,125, this function fails. If we go and fix this, the formal verification error goes away. And that lets us be 100% confident that for all possible values of this function's input, it behaves the way we want. Now you ask, this is absolute value. What's the usefulness of this? Well, it's actually very relevant to blockchain software. Consider, for example, a coin transfer, where you're transferring some amount from one account to another account. If this transfer is 5 coins from me to you, all is well and good. But if this transfer is -5 coins from me to you, if you didn't have some kind of checking for the invalid negative number case, that would result in 5 coins being transferred from you to me, which we absolutely don't want to do without having a signature from your end of things instead of my end. So this is very relevant to real-world programming issues. And it's also very conceivable that someone could write some really inscrutable code that cleverly embeds, quote, a backdoor, as it were, into the contract and allows them to siphon money away from people. You could do all kinds of crazy things. Whatever your imagination can come up with, you could say, oh, if the block number is an even block number, then do the right thing. But if the block number is odd, then steal all their money. All kinds of things. And this formal verification infrastructure allows us to guarantee by way of actual proofs for all possible values of your input that your function behaves as you want. And the common retort, I guess, of, oh, but we could just do this with a test suite. This example here is meant to demonstrate, no, you probably couldn't, because are you really, truly going to think to test -4,839,000? Probably not. You might test a lot, but you're not going to test that many numbers. Now, next I would like to demonstrate how we interact with dApps with our Chainweaver wallet infrastructure. So this application is our web app, but we have a desktop version of basically the same app, and it is evolving very rapidly into a more consumer-focused wallet, which will be released later this month. And that is right here. It's a little bit hard to see. I'm going to pull up another tab just so we can distinguish the browser. This is actually a native app running on Mac OS, and it's running the same code that we just have. The advantages that this gives us is it's on your computer. If you want to store keys, which you need to store keys in order to interact with the blockchain, you need to sign contracts. We very quickly realized having an in-browser method for this is not the most safe and secure way that we would like to operate. We would like this to exist on your computer, and we would like these things to be encrypted and have best-in-class key management hygiene. And so that's what we are achieving here with the desktop app. As you can see, we have a few accounts here. We also have the same ability to work with contracts, to investigate things that are on the blockchain. Very similar to the web version, except this is on your desktop. Now, how does this interoperate with a dApp? This is something that we feel like we have a really nice, elegant solution that distinguishes ourselves from the rest of, or a lot of the other blockchain smart contract systems. If we go to our testnet portal website, which Stuart mentioned on his slides, we have a nice getting started set of steps here. You can download the wallet for Mac OS. You can get coins with a coin faucet, and you can play some games that just demonstrate simple and easy things that show you all of these pieces fitting together. So let's take a look at the games. We have this little parrots game. Basically, it's a dice game. You pay to enter. You play a few rounds, and if you can either stay or cash out. And if you wait too long to cash out, you might lose your money. We also have this lotto game, which we are collaborating with a third party, and that's coming soon. So if we look at the Pact parrots, what is the structure of a blockchain dApp? Well, dApps are really at their core just normal web apps that also talk to a blockchain. They're going to talk to the normal web backend server, but then they're going to send some messages to the blockchain to accomplish whatever it is they want to accomplish in a more durable way. So this app just sent some messages to the server. It downloaded the current state of the leaderboard here. Whoever has won the most coins. We see Nick Cage is doing particularly well. I have chosen an account up here in the corner. My account name is Mighty Byte. This is different from a login because we're not actually logging in. There's no password here. All I'm doing is I'm just telling this dApp to use this account name, and the wallet is going to handle all of the signing and authentication that we need to do the blockchain operations. So now if we click Start New Round, whoa, what just happened? The dApp sent a message to localhost, to my computer on a certain port where the wallet was listening. And the wallet gets that, sees that it's a signing request, and pops up information for you to know what you're signing. And you can see here we have the exact raw command. That makes it a little bit less visible, but Pacty Parrots 2.startRound Mighty Byte. This is where we really leverage the benefit that Stuart mentioned of human-readable code on our blockchain. This is exactly the transaction that's going to go in, and you want the user to see and know precisely what is going to be done. And they can see that here. So you can go through, you can verify everything, you can set your transaction parameters, how much you want to pay for gas, any kind of gas limit. For now, we'll just take the defaults. And here's where the capabilities that Stuart was talking about comes in. We have a gas capability, which is required to submit a transaction to the blockchain. And then we have a transfer capability, which is required to pay this start round fee of 5 coins. And we can see very clearly, coin.transfer, Mighty Byte, Parrot Bank to 5 coins. This is what I'm staking in terms of losing from my account if I choose to sign this. I look at the drop-down. These are all the accounts that I have available. I see that it's Mighty Byte there, and so I'm going to sign with account Mighty Byte. I hit preview, and it tests the transaction. We see server result write succeeded, so let's confirm the signature. The wallet disappears into the background, and now we're waiting for the transaction to go into the blockchain. While we're doing that, let's go look at our block explorer. And we can see this transaction come in. This is a block explorer running on our testnet right now. You can see this is multi-chain. This is Chainweb. We have 10 chains. They're braided together. When you hover over them, they show you exactly which neighbor chains they are linked to, which gives us our security guarantees. And here you can see on chain 0, we see 1 transaction just came in. If we go back to the parrots game, we see, we rolled the mustache parrot and the purple parrot, and we have a total of 20 points, and now we're 15 points up. If we go back to the block explorer, we can look at this block and go down to the transactions, and what do you know? We see here, Pacty Parrots, start round, Mighty Byte, and we can look at all the information, we can see the signatures that were associated with it, and see exactly what happened in the blockchain. Then we can continue playing this game, we can go through this again, we can spin again, we can cash out 15 coins. These are going to send more transactions into the blockchain. In these cases, they don't require money, they only require the gas payment. And that's where Stuart's point about having gas stations can come in, because you don't have to be the one to pay this gas. The way we have it currently set up, you are the one that pays this gas, but there are lots of flexibility and possibilities for how we might be able to structure gas payments in the future. That's pretty much, I think, the summary of what I had to talk about. In conclusion, our mainnet mining is live. This block explorer, it is exploring the testnet right now, but we can change it and we can have it be watching mainnet. This is our actual live mainnet, getting about 5 gigahashes per second, and you can see the blocks come in. We're really excited that we've gotten this out the door, and we're anxious to see the users and see what people start to do with this stuff. Our token sale is live on CoinList. If you want to engage with us, find out more, you can join our Discord. Thank you so much for coming out. We'll be around for a while to answer questions, and don't forget to pick up a swag bag before you leave. Thank you very much.
Cool. Should we take a few questions now?
Yeah.
Any
Yeah, we
questions?
can take some
One
questions.
question.
Yep.
How big is the JavaScript library you need to implement or you need to use to be able to build it out?
What units are you interested in?
Lines of code.
Lines of code that like I had to write to build this
The
app?
Pact
Oh, the Pact.
JavaScript library in Java, like the JavaScript API library.
Actually, I don't know off the top of my head. It's not very big. It's a few hundred
How big is
lines,
it?
I think.
Between 400 and 500.
Yeah, 400 and 500 lines of code. That's the JavaScript interface. So if you want to build a dApp, you would import this library, and it talks to the blockchain and handles all of the transaction and the signing API for you.
I have a follow-up. How big is Web3, which is what you need to use for Ethereum?
That I do not know.
Do you have any idea?
I don't know, but I'll add a few zeros to that.
Couple orders of magnitude.
Question over here.
You're trying to go after enterprise or even gaming system or like gaming dApps of the world. What is the roadmap to actually try to go after all the main players that are pretty sizably ahead at this point?
I think we've put out the thing that we have. We think it has a bunch of advantages, and hopefully we can gain some traction. We're working very hard to get our name out there, market, and try to build a developer community. I don't know, Stuart can maybe address a little bit more some of the other roadmap items.
The main thing is, one of the things we've been really focused on is business and enterprise adoption. That's why we're working with USCF. That's why we're working. There's some other exciting partners like Remedy, and some of these people bring real use cases to our blockchain. So it's basically we want to make steady steps towards increased adoption of our blockchain platform. And as far as that goes, adoption is one of those things that kind of proves itself, in the sense that if people are getting real work and real utility out of our blockchain, and they're able to bring things to market quickly and without a ton of expense, we feel like we've already succeeded. Now, when people talk about an entrenched marketplace, we're talking about an entire ecosystem that's only existed for 3 years, and a developer community that certainly, while something like Solidity has many developers, it is absolutely swallowed up by something like any standard language like Go, Java, C++, or anything like that. So we don't really focus too much on the concept of like there being entrenched leaders. They're not entrenched. I mean, Ethereum is busily working on Ethereum 2.0, and that's going to be a drastically different, in fact, it's not even going to be backwards compatible with Ethereum today. So they're ready to throw out their entire original architecture. So that just gives you an idea where we're at. The model to look at is like the web in like the late 90s. The web was already able to do some pretty exciting stuff. You already had Google, you already had Amazon, you had a lot of you had people making money on the web. But people hadn't really figured it out yet. And so what we basically want to do is provide kind of the building blocks for people to be able to start telling a new story about how we can bring real applications to people in blockchain.
So, follow-up question then. So, why then? So, mostly agree with most of what you're saying regarding I don't think we've even seen a Google emerge yet. I think we're still like that Netscape, Excite, web crawler era still. But why? I guess it's like why proof of work then? Of all the sort of consensus reasons out there.
I will concede the proof of work is a conservative choice. So we're engineers. Sure. We're people who think that Bitcoin introduced something brand new to humanity, which is, in addition to introducing this coin, it also introduced a consensus mechanism that could run itself. So one of the things we wanted to do is show that proof of work is capable of scaling. Because the main criticism against proof of work at the end of the day is that it doesn't scale. Once people decide...
It's also the energy resources, like a massive amount of energy resources.
Correct.
Yeah.
But if you can take the same energy resources and get more utility out, if you can horizontally scale with the same energy resources, the debate shifts Because right now, what's happened with Bitcoin in the past 6 years is that you've had this huge rise in hash power. And what utility has it gotten us? It's gotten us nothing. Bitcoin is the same system it was 16 years ago. It just consumes a tremendously larger amount of hash power. With Chainweb, what you see on here is a 10-chain configuration. And this is the configuration we're launching with. We've already generated more blocks than Cosmos. We're on track to generate more blocks than Ethereum has. I know that sounds like weird. I'm not going to say what it sounds like. But but the point being is that we're not doing transactions yet. Once we're doing transactions, you now have a scalable system. And the important thing about Chainweb is Chainweb, at any point in time, we can add more chains to this, and actually the entire difficulty of each chain goes down. So the point is that Chainweb maintains the same efficiency where it's running 10 chains, 20 chains, 100 chains, 1,000 chains. So at any time, we can increase the efficiency of the system. This is something that Ethereum today, and Ethereum's moving to a different architecture, but Ethereum today, Bitcoin today, none of those things can do. And so the real question you have to ask is, what are you getting for the power? Does it use up power? Yes. Now, we all know that most industrial scale miners are not firing up a coal plant to run their things. They're usually using excess energy that wouldn't be used otherwise. But the real thing is that we're at a stage of development of blockchains right now where consensus systems are not proven. If you look at proof-of-stake systems, they are in danger of being tremendously centralized. It's really not hard to imagine how a proof-of-stake system can be dominated by an oligarchy of the people who have the most coins. And nobody really has a good answer for this. And everybody's just, what most people are pointing to is they're saying, yes, but it scales. Okay, it does, it offers some features that Bitcoin doesn't have, but what Bitcoin brought to us was a truly decentralized consensus. And so we want to solve one problem at a time. And there are other efforts in Nakamoto consensuses. So for instance, Chia, what Brand Cohen and all. There's nothing, in fact, there's nothing about Chainweb that couldn't even switch to proof of stake. But we actually don't believe in proof of stake. We think proof of stake represents, most proof of stake networks are classic Byzantine fault tolerant networks, which means they have a hard upper bound on how many transactions. Chainweb scales infinitely. It scales on bandwidth and mainly bandwidth. That's the main limit on how many chains you can run. So in that regard, and then we could switch to a Chia, we could switch to other truly decentralized consensuses, but these things are developing very slowly. So we basically believe in blockchain, in public blockchain, and we think the proof of work is the only proven consensus. So we want to solve one problem at a time, and that's why we made Chainweb a scalable proof